Hello, my name is Sierra and welcome to my channel, Homemade Mathematics. My past two videos we were talking about expressions, and today we are finally going to talk about equations. If you don't know the difference between an expression and an equation, I suggest going back to watch one of those videos first. But basically the main difference between an expression and an equation is an equation has an equal sign. Before, when we were looking at expressions, we could either simplify them, or if we were given the value of the variable, we could evaluate them. But we could not solve because there was not an equal sign. Now with our equations, we can. And what I mean by solve is find out what that variable represents. Before we could simplify or we could figure it out if we were given it, now we're going to be able to find it for ourselves. So we are going to be solving one-step equations in this, but before we can do that, I want to take a look at how equations work and why we solve them the way we do. To do this, I'm going to start with the most basic equation. Let's go ahead and take a look.
So we have 2 equals 2. I hope we can all agree that this is a true equation. I like to think of equations as a balancing scale like you can see here. On both sides, it is equal, so they are also balanced equally. However, if I were to add something to one of the sides, so let's say I were to add 3 to my left side, these are no longer balanced, so that means they are no longer equal. So what would you have to do to the right side to make it equal the left side? The same thing we did to the left side, which is one of the main points of solving equations. Whatever you do to one side of your equation, you have to do the same exact thing to the other side to keep that scale equal and balanced. So as you saw, I added 3 to the left, so to keep the right balanced, I had to also add 3. But what if I had that unbalanced equation, that 5 equals 2 again, and this time I said you need to do something to the left side to make them balanced. So remember before we added 3 to the left side, so to undo that, the opposite of add is going to be subtract 3, which would bring that back to 2 equals 2, and they would be balanced again. All right, this works the same with our other operations as well. If I multiply by 3 on one side, I now am unbalanced, and to get rid of it, I would divide by 3. So to undo things in an equation, we're going to do the opposite operation. Let's take a look at what that looks like with some examples.
Alright, so I have 10 problems here. You can see the first 4 I'm starting off with whole numbers, and then like I said, I move on to some integers for the last problems down here. So just like we saw in the animation before, we're going to do the opposite operation to get rid of it, because we are solving for our variable. We want to know what is x. Right now, I don't know what x is. I know what x plus 5 is. Okay, but I don't want to know x plus 5, so I want to get rid of this plus 5, which we saw we're going to use our opposite operation. So instead of add, we're going to subtract our 5, because a positive 5 minus 5 would get us 0. So x plus 0, that's really just the same thing as x. But like you saw, our equations are like a scale. If you do something to one side, it's no longer going to be balanced or equal. So we have to do the same thing to the other side, which what did we do to the left side? We subtracted 5. So what are we going to do to the right side? Subtract 5. Which 7 minus 5 would get us 2. The great thing about equations is you can check your answer and guarantee you got it right every single time. So on your next test with solving equations, you can guarantee you get 100% on those equations by checking your answer. Right? We said our answer is 2, that x equals 2. So let's see if that works. Is that true? All right, instead of our x here, we're going to replace it. And we said it's no longer x, it's now 2. Does 2 plus 5 get me 7? Yes, so we know we did it right. Moving on to number 2 here. Same thing, we're going to do our opposite operation. So right now, what is with our x? We have x minus 3. So how would I get rid of minus 3? We would have to add 3. Right? Because if we were at negative 3 and we went up 3, that would get us to 0, which would mean we're just left with x. But whatever we do to one side, we have to keep it balanced. If we add 3 to our left side, then we have to add 3 to our right side, so that we get x equals 9 plus 3, which is 12. We're going to go ahead and check that. Instead of having x, we're going to have 12 minus 3, which does 12 minus 3 get us 9? Yes, it does, so we know we found the correct x. Number 3 is a little different because we have a number next to our variable, which we should know means multiply, which the opposite of multiply would be divide. So if we divide this by 5, right, 5 divided by 5 would get us 1x, which 1x is just the same thing as x. But just like with adding and subtracting, with multiplying and dividing, same thing. If you do it to one side, it's no longer equal. You have to do it to both to keep that scale equal on both sides. So 40 divided by 5, we get that x equals 8. We can check that. 5 times 8 does get me 40. We know we have the correct answer. Number 4, we have a fraction, or what looks like a fraction. We have x over 6 equals 4, but we should know fraction bar just means the same thing as divide. So this is the same as saying x divided by 6, which on the last problem, to get rid of multiply, we divided. So to get rid of divide, we're going to multiply by 6. I'm going to write it this way. We're going to multiply by 6. Okay, because if you can see this, if 6 is a whole number, any whole numbers over 1, right, those 6's are going to cancel, and we're going to be left with just x. Okay, but we multiplied by 6 on the left side, so we have to do the same thing to the right side. 4 times 6, 24. Let's go ahead and check that. So if we replace x with 24 over 6, does 24 divided by 6 get us 4? Yes, it does. We know we got it right. These next few might be a little trickier because they are integers, which might confuse us a little bit. For example, with number 5, yes, we have x plus a negative 3. Right? Before I told you, right, if you have add, you want to do the opposite operation, which is subtract. However, we're adding a negative 3. Right? We want that to be x plus 0, not x plus negative 3. So how would I get rid of negative 3? Right? We would have to add a positive 3. Then those would cancel. Negative 3 plus 3 would get us 0 plus x, which is the same thing as just x, equals whatever you do to one side, have to do to the other. So we added 3 on the left side. We're going to add 3 on the right, which negative 8 plus 3 would get us negative 5. If you need practice with your integers, adding and subtracting integers, I do have a couple of videos for that you could check out. And then we're going to go back in and check our answer. So negative 3 plus, instead of x, we're replacing it with what we think x is, which is negative 5. Equals negative 8. Is that a true statement? Negative 5 plus negative 3 does get us negative 8. So we know we got the right answer. Right? Number 6 looks a little different. Notice this time x is on the right side of my equal sign. So I'm not moving this 12. I'm moving what is with my x. And my x is not on the left this time. My x is on the right. So what's with my x? Minus 4. We don't want x minus 4. We want just x. So how would I get rid of a negative 4 or minus 4? We would add 4, both sides.
Those would cancel so that we're left with x, and negative 12 plus 4 would get us negative 8. We can go ahead and check that. Negative 12 equals, and we said x is negative 8, so negative 8 minus 4 does get us negative 12. That's a true statement, so we know our answer is correct. Moving down to 7 here, a lot of people will mix 5 and 7 up. They'll think they're the same problem, and they'll just go ahead and add 3. All right, but notice there's not an operation in between my negative 3 and my x this time, right? Before there was that plus sign, there's nothing there, which if there's not an operation in between, we know it's multiply. So how do I get rid of multiply? We divide. So we want to get rid of that 3 because we don't want negative 3x, we want just x. But we also don't want negative x. You notice if I just left it like this, negative 3 divided by 3 would get us a negative 1x or negative x, which again, I don't want to know negative x. So we need to divide by that whole number of negative 3. Because negative 3 divided by negative 3, anything divided by itself gets us 1x or just x. Do it to both sides. A positive 12 divided by a negative 3 gets us a negative 4. We have negative 3 instead of x. We think x is negative 4. Does that get us 12? Yes, a negative 3 times a negative 4 does get us a positive 12. So we know it's right. Number 8 here, just like the one up here, number 4, right, that fraction bar, we know that's really just saying divided by negative 2. So how do we get rid of divide by negative 2? We would multiply by negative 2. Remember, we have to keep that negative in there so that those negatives cancel out and it gets us a positive x. Do it to both sides. 9 times a negative 2 gets us negative 18. You can check it. Negative 18 divided by negative 2 does get us positive 9. All right, number 9 looks kind of tricky, but kind of not if you think about it. All right, so if a negative x equals a positive 7, then we should expect a positive x to get us the opposite, which would be a negative 7. Okay, the way we know this is true, how can we get rid of a negative sign? Right, we can either multiply by negative 1 or divide by negative 1, and we would have just that x. So if I multiply or divide both sides by negative 1, I'm going to end up with that negative 7. And then lastly, number 10 here, I'm actually going to do a step first before I go to solve because I see 2 negatives, which I do not like double negatives, right? Because double negatives really just make a big plus sign, right? This problem is really just x plus 6 equals 5, which we don't want to know x plus 6, we want to know just x. So to get rid of plus 6, we would subtract 6. Make sure you do it to both sides. Those cancel, and x would get us 5 minus 6, a negative 1. Again, we can check that. Negative 1 plus 6 does get us a positive 5. So like I said at the beginning, always check your work and guarantee yourself 100% every time.
Thank you for watching, and I hope you enjoyed this video. If it was helpful, please give it a thumbs up and comment down below what you would like to see next. I will be putting out a part 2, which is our 2-step equations. So one more step than these equations we looked at today. So go ahead and subscribe so you don't miss that next video. Thanks, and we'll see you next time.